Hi, so this talk is called Functional Programming in Anger. It's the first time I've given this talk. It's slightly different from some of the talks I've given, I think. Though, there'll definitely be some things you've seen before, but hopefully some new stuff. So this talk isn't really about functional techniques or, sort of the specifics of functional programming. It's much more sort of an experience report as somebody who has led the development of ClojureScript, which is a version of Clojure that compiles to JavaScript. And so I have the benefit of working on the compiler, but also I work at Cognitect for the past 4 years, and I've seen how people use it in the real world. So I'm using it, and I work on it because I want to use it, but I also see what happens in projects that started without, a lot of guidance, or, people who just started doing functional programming, and that's definitely heavily informed the development of ClojureScript, and of course, in many ways, Clojure as well. So I just kind of want to talk about what's it like to use functional programming in Anger for quite a few years. So again, if you're not familiar, Clojure is a functional dynamic programming language for the Java virtual machine. It's a Lisp. I feel like it's definitely the most popular Lisp that's probably ever existed. I mean, these days when you see some Clojure code online, it's not weird, which is amazing. Definitely wasn't the case when I started doing Clojure 10 years ago. ClojureScript, it's a version of Clojure that was released in 2011 by Rich Hickey and other members of Relevance. I sort of got involved early on because I had a lot of JavaScript experience and then sort of kind of took over the project. It's a version of Clojure that targets modern Java virtual machines, JavaScript virtual machines, excuse me. Java has a lot of course, optimizations in it. And then it turned out, because of the sort of arms race around JavaScript engines, many of the tricks that appeared in the JVM now exist in JavaScript. And you can get the same crazy performance from persistent data structures on JavaScript engines that you can get from the JVM. So it effectively is Clojure, minus, of course, the concurrency stuff. So where did I get this phrase from, functional programming in Anger? So again, I started doing Clojure as a hobby in 2008, and the only way to find out anything about this language, besides reading the sort of, the sparse documentation on the Clojure.org website, was to log into IRC on Freenode, because Rich Hickey was hanging out in the Clojure IRC channel. So I would hang out in the Clojure IRC channel and try to absorb some of the greatness. But he, of course, he was very vocal about, Clojure was inspired by Common Lisp and Scheme and Haskell. And I think people were asking about Haskell, and he was like, Haskell's great, though I've never used it in Anger. And that phrase just stuck with me. And it just means that, I never actually had to use it on the job, right? On the job, you're often doing things, regardless of whether you love the tools or not, you're not always using them happily. So that's where that comes from. But again, so I've been doing Clojure for 10 years. 6 of those years was as a hobby and or open source project maintainer. I worked on Core Logic, which is an adaptation of Minification, which is a thing created by Dan Friedman, Will Bird, and Oleg Kislyav. If you're a Haskell person, you probably know who that is. So that was like an embedding of a pure version of Prolog into Clojure, and that was a lot of fun. I also did Core Match, which I took a OCaml paper by Morange, who I don't think it was ever implemented in OCaml, but it was a much better algorithm for pattern matching, and I implemented this as a macro for Clojure. And then for the past 7 years, I've been leading ClojureScript development, and for the past 4, I've actually been using functional programming in Anger. So prior to that, I was at the New York Times doing Ruby and JavaScript, but for the past 4 years, I've been at Cognitect. 2 years I was there, I was doing writing a functional database, Datomic. It's a purely functional relational database written completely in Clojure. So I worked on that for 2 years. And the past 2 years, I've been working on the consultancy side, which means I get to go and see how other people are using Clojure, ClojureScript, and Datomic. And of course, you see all kinds of things. You walk into projects that are amazing, and then you walk into projects that are messes, as they would be in any programming language. And generally, after doing this for quite a bit of time, I mean, it's definitely my feeling, having done a lot of open source development and having done quite a bit of commercial development with functional techniques, functional programming alone won't solve most or even many of your problems. It just won't. And I definitely think it's a narrative that we should embrace. We should give a much more even-keeled picture of what functional programming can do for your software. One thing that I think that is missing, I often see people talk about programs, and the truth is the program is one tiny thing of whatever you're doing. And I think a lot of Rich Hickey's later talks, people talk about his early talks, but a lot of his later talks are what happens when you take functional programming to a higher level, a macro level. What does it mean for your architecture? What does it mean if your database is purely functional, right? That completely changes the types of programs you're going to write. And I don't hear enough of this type of higher level thinking from the functional programming community. People, again, they focus too much on individual programs, and I think that nobody will be convinced. The engineering community in general wants to hear, I think, a wider narrative. And I'll touch on some of these things. Again, but I do think that functional thinking can widen the scope of the types of problems you can solve, but not by much. Even if you do all these things, in the end, my experience is that software projects crash and burn, largely because there's issues with process and with people. It's not much to do with technology. But I'm not going to talk about that. We're going to talk about programming languages and using them in anger. That's what we're going to focus on, but that was sort of my philosophy about all this. We do want people to use functional programming, right? I think this applies to paradigms as well as programming languages. Bjorn Stroustrup has a very famous quote. There are only two kinds of programming languages, right? The ones that people complain about and the ones that people don't use, right? That's all there is. There's the stuff that people complain about and there's stuff that people don't use. If you want your thing to succeed, it better be something that people complain about, right? You want to hear complaints. And in fact, this whole talk is, what are the types of complaints that I've heard as a maintainer, and how has that changed the development of this particular functional programming software project, hopefully with some takeaways for you all. To sort of kick this off, I did Rails in 2010, and Rails for me was an interesting moment. There's another one, of course you could pick any, but I think Rails was particularly interesting because, of course, I've spent a lot of time on the web. I did a lot of web stuff. And Rails, when it came out, I watched, raise your hand, who was around when they saw that first demo that DHH gave? Also, not that many. Wow, okay. So this maybe, you may not completely understand what I'm saying. But anyways, when it came out, it was a shockwave. It was a shockwave because people didn't realize, people knew that it was really ridiculously difficult to set up a website, but until DHH did his first Rails demo in 2004, where he basically built a CRUD application in 15 minutes. I mean, had never been seen before. No one had ever seen this. And that sort of kicked off about a decade of, I would say, growth. And of course, that's leveled off. But that was like a huge moment for people that were doing web stuff. People just went to Ruby on Rails, in hordes. But it really showed something, because I think Rails, whether you like it or not, it's not important. What it did show the community, the software engineering community at large, was building websites was too hard. And in fact, you can look at across all languages and stacks, and almost everybody adopts the Ruby sort of configuration as convention and sort of automation as a way to eliminate steps that we do not care about. We don't want to spend brain cycles on these details, right? And in fact, if you mess it up, it's just going to cause problems. Automation is important. For me, I really see this as like the beginning of people really embracing automation as a thing, and that's great. The other thing about Rails is that was an amazing demo, and when Clojure first came out, people were like, oh, Clojure needs its like Rails demo, like something that just shows that there's a killer app. And at the time, I was very skeptical because I really felt that the Rails thing was like kind of a one-time thing, right? Once people saw it, people said, oh, we can do that for our stack, our language. And I was very skeptical that alone would make any language, definitely not Clojure, successful. And I think that mostly turned out to be true. But before I go into that, I do want to show a demo. What's modern ClojureScript look like? I don't assume that people have seen this. And in fact, when I often give this demo, people are like, oh my gosh, I didn't realize that Clojure and ClojureScript had come so far along. So this demo that I'm about to show, it's not like Rails. Rails was really like a very small team of people when it came out, and they did that whole thing. And yes, it was open source, but it was a very small team of people that made that first demo possible. The demo that I'm about to show you is very different. It's the result of people using Clojure and ClojureScript in anger over the past 10 years. People working independently have all done the pieces that are going to make the demo that I'm about to show work. So here, I have a file. It's a ClojureScript file. I'm in IntelliJ, right? This is running a commercial plugin called Cursive.
I'm going to launch a REPL. This is going to start a ClojureScript REPL, a process. I'm in my text editor, right? So I can change this code, and we're going to see in a second. The browser will open. So here I have a trivial application. I'm typing expressions down here in this REPL, and what's actually happening is it's taking that expression, compiling it to JavaScript, sending it to the browser over WebSocket, evaluating it, and taking the result, and then printing it back out. So here I have, this is a React application. This is React. This is actually React. I have Figwheel running. Figwheel is a hot reloader. So if I'm over here and I change the font size, and I save this, the font size over here will change, and if I go, I want the color to be blue, that will change. And this is all live. And if you've tried to do this in JavaScript with the modern JavaScript toolchain, you'll go crazy and lose at least 2 days, I think, setting it up. Whereas here, if I look at what's in this file, this is my 5 lines of dependencies to make this work. Just ClojureScript, reagent, which is the React binding, and Figwheel, which does the hot code reloading. I don't have to do anything to configure Figwheel at all. There's no configuration. This is the same if I was just building this project without hot reloading. I don't have to do anything to my code to get this to work. If I go back to my source file here, and so this is completely live, and if I'm down here and I go ahead and take the app state. So what's happening is I'm not refreshing the page, right? This page is just running, and then I'm going to change, whoops, what happened here? I'm in the wrong namespace, so let's go in the right namespace and do that again, right? So this is not reloading the page, and this is how ClojureScript developers build massive applications. Like there's Circle CI, it's a continuous integration thing, and they built their whole thing in ClojureScript, and this is how they dev. They never refresh. Like the app state is just there, and they can just modify it. They can be at whatever depth they need to be in the UI state, and then change a style, change a piece of state, and they don't lose the context. This is how people have been doing professional ClojureScript development for at least 4 years. This is not new stuff. One other thing is that, the other nice thing here is that, okay, I can click on the console, and if I go over here to sources and I refresh, there I am. I have a breakpoint, and here I have the stack trace, and if I go down to the bottom here to the locals, here you see that I have inside the stack frame, I have the locals captured and it's being printed as ClojureScript data structures, right? So I've shown you IntelliJ, I've shown you source mapping, breakpointing, all this stuff. And this is all independently developed. No one person worked on anything that I'm demoing here. Okay. So there are a few reasons that are possible. I mean, one thing I think that makes that work is that, I think the community does sit around one set of values, which I think is well described by this talk. If you haven't seen it, I highly recommend it. Simple made easy. It's a great talk. The live coding stuff works because we are already doing functional programming, right? When React came out, I realized you could take the functional programming idea, React, and then Bruce Howman, I was like, I showed all these cool demos, and then Bruce Howman had, the next leap was that, live coding is just falls out of what we're already doing by convention. It requires no training, no special stuff. It just falls out of functional programming, and React is a functional rendering layer. Okay, so that's a cool demo. So that's where we've got to, and we have further to go. But I sort of want to kind of describe what are all the steps that we had to struggle through to get to something like that. So as the maintainer, I've seen over 7 years many kinds of users. And so I'm going to sort of classify them. They're all kind of important. There's, of course, you could go further, but this is just a high level, my idea of what the types of users I've seen over the years and how they've informed the project. This is for only a very short period of time you get this, right? This only applies to the beginning of a project. So you have the early adopters. I'm going to use the development of the synthesizer as a sort of analogy. So synthesizers, people were very excited about electronic music, but people were like, okay, that's cool, you can make those sounds, but what kind of music are you actually going to make? So this is the prototype, Moog. I believe this is Herb Deutsch, who bought it when it was wasn't even done, and then Moog completed it just for him, and he started making music with it. Early adopters are great because they see the potential, they're excited about new possibilities, but again, they only last for, that period only lasts for a shorter period of time, maybe 2-3 years. And that's great, but again, early adopters tend to be a very small population. And if you look at the history of Moog, I mean, it really blew up when popular musicians started using it. That's when Moog started making money. It was cool that these sort of academics and classical composers, serious composers, were interested in this technology, but that was never going to lead to the wide success of a synthesizer manufacturer like Moog. So early adopters, important because they they allow you to gauge the market, they allow you to gauge the level of interest. But you definitely quickly have to think, well, how do we get to the wider audience? Something else that you observe are tinkerers. These people are great, but they tend to come and go. The analogy here is there's a new phenomenon in the sort of the synthesizer enthusiast world called the Euro rack. It's this sort of standardization of the module so that you can buy lots of tiny little modules. But it's a very much there are some, of course, professional musicians, tons using this way. But of course, it makes sense for hobbyists a lot because you can just keep buying modules. People release new modules like every 6 months, and people are constantly swapping them out. And the analogy here is that you have lots of people who just are trying lots of new technologies. People who never intend to seriously use it, but they just want to play with the thing. And they make a little toy thing, maybe they make a game, whatever. But at the same time, these people are useful because they can often capture low-hanging fruit, things that you've missed that you should address. So they are definitely good in sort of like finding low-hanging fruit. But again, my experience is that they come and go. Somebody submits one patch, and you never hear from them again. Okay. And then you have, I think, the two sort of class of users that really affect the life and the sort of the sustainability of the thing that you're trying to do. And the first class is I would call enthusiasts. These are people, like the analogy here is that people who basically have made the leap, I want to invest in this thing because I want to do that thing in a serious way. So, if you look at music equipment, there is stuff that's more expensive. It's not as expensive as the most expensive stuff, but it's more expensive. And it does involve a commitment, right? You're like, I'm spending X amount of dollars for this thing, and I really want to see if this is working for me. The enthusiasts are great because those people often tend to get involved in the community. They start doing open source projects, and those things often feed back into what you're trying to do or your attempt to understand what needs work. So quite a few open source things have happened this way. I would argue that Figwheel, the hot reloader you saw, as well as the thing that gives us the printing of ClojureScript objects in Chrome, those people started as enthusiasts. And what's great about enthusiasts is that they often, very quickly thereafter, become professionals because they like the thing so much and they spend so much time on it that they actually want to get paid to do it. Right? That's what you really want to do. You want to get paid to do the thing that you like. And these people are the people that really, truly will guarantee that your project will stay around for years. Because what they've done is they're banking their business on your technology. Right? They're writing software. They're building something that most definitely will become legacy. Right? The final result of any piece of software, it's a legacy thing you have to maintain. Right? That is an absolute fact. Right? Functional, not functional, it doesn't matter. You're going to make bad decisions, you're going to write software, then you're going to have to maintain it. So it's an investment, right? So this is the Moog 1. Moog just recently released it. It's their first polyphonic synthesizer in 2 decades. It costs more than $10,000, right? This is not a toy, right? The people that are interested in this are very serious. They have budgets, they have studios, they're making records. Those records are going to sell. It's a very different class. These people are in it for the long haul. And again, these are definitely the type of people that you really want to listen to. What's missing in our technology that you need to succeed? Okay, so supporting Angular users. What does this look like? Clojure is a bit more straightforward because Clojure is on the JVM, and the JVM is really slow, right? It takes forever for them to do anything. Recently, there's been a bit more churn around Java 9, but it's unusual. Usually, it's 2 years, and then a year after that, people are like, yeah, I finally upgraded Java. So it's a very slow process. So supporting Angular users on the JVM, it's not so challenging. ClojureScript, of course, it's much more difficult because JavaScript churns, right? It's never, I would say we're actually reaching a point of stability largely due to React. But prior to React finally just obviously being the one that's going to win, it was very much a landscape of what the hell is going to happen next? You don't know. And of course, it's something that targets JavaScript. We have to deal with this. And so a lot of what I've been doing is just observing our communication channels, whether that's our yearly surveys, where we survey the existing user base, the mailing lists, IRC channels, and Slack, right? Just listening to what people like, what people don't like, and what's sort of painful for them. Again, just to repeat, the tinkerers enthusiasts are great at finding the low-hanging fruit, and angry users are the ones that push for the features that are used to. So angry users are often, again, they're people that were serious and they switch because they were like, okay, I'm doing something serious and I want a user thing to do this serious thing now. And they have certain expectations, whether it's coming from Rails and they're like, I want something that has a bit more convention on the configuration. Or they're coming from JavaScript and they're like, I really want code splitting because I'm used to that from Webpack. And these are things you have to listen to because those things actually solve real problems that they have, whether that's the latency of the time to load their rich single-page app or whatever, right? They have an expectation that's real. It has nothing to do with functional programming or not functional programming. They're a certain metric that they're looking for. Again, but at the same time, some of these things that you'll hear about are gaps, and some of them are about ease in documentation. Often people come to ClojureScript and they're like, I want X. And you're like, well, that's inside of Google Clojure library. Just go look there. So a lot of the things is it's a mix of what's actually missing and what is it just because we haven't documented it well enough and people don't know about it. So you definitely have to do some filtering here. But one thing that I think has definitely informed ClojureScript is, and Clojure to a large degree, I think I now have a deeper appreciation for the way that Clojure has been marketed and what Clojure is intended to do. And this very much influences Clojure. And this is based off this quote from Gerald Sussman, the author of The Structured Interpretation of Computer Programs, one of the greatest books on computer science, I think. But there was a huge uproar because MIT switched away from Scheme and functional programming to Python in the early 2000s. It used to be that the intro class for almost 30 years was all in Scheme and taught the MIT intro students functional programming. It's great. It's amazing. And even go into things like interpretation, metacircular interpreters, compilers, awesome. And his explanation for why they switched away was that what people do in the market, in the actual real world when they're doing software engineering, is that they're generally not in control of all the pieces of their software, right? There's this thing nowadays. It used to be you could understand everything, but nowadays you muck around with incomprehensible or non-existent man pages for software you didn't write. Right? That's what I do. I'm sure that's what you do. You're looking for X. You go on GitHub. The thing is documented badly. You read the source code. Okay, this does what I want. Then you add that as a dependency and you do your thing. Right? So much of software development is Stack Overflow, looking for depths that solve the problem that you have. We're pulling together things. Right? The platforms that we develop on have so many features. Whether it's AWS, whether it's the browser, it's a cobbling together of existing stuff. We're no longer starting with primitives and going there. And I think that functional programming, it's great, of course, but the type of tools and the way that we should be talking about things should accept the modern reality of what software development's like, right? Functional, the part of your program that's functional, that's cool, it's simple, it's pure, but your story for how you interact with the rest of the world needs to be really, really, really good. And I would argue that for both Clojure on the JVM and ClojureScript targeting JavaScript, all the struggle has been making that better, right? Making our ability to interact with the wider world better for the end user. So again, ClojureScript came out in 2011. At that time, 7 years ago, it was unclear what anybody wanted, right? Because the people that were doing it didn't know what they wanted, right? In 2011, at the New York Times, we were still inlining script tags, right? Some people were using Bower, which was like this client-side build thing that was sort of stuck into NPM just to grab the depths. Some people were using Browserify, which would magically convert your node programs into things that could run in the browser. In hindsight, we were lucky. Right? We were very lucky that it was so chaotic at that time because it allowed us to be patient. And when ClojureScript came out, ClojureScript was built very much on top of Google Clojure, which we'll talk about in a second. And Google Clojure does some magical things. And most people were not familiar with it, right? Hardly anybody in the JavaScript community knew about it. And even in the Clojure community, we didn't know that much about it. So the fact that everything was churning in the JavaScript world was a benefit because it gave us time to understand what can Google Clojure do that other things aren't doing. So we'll dive into that in a second. But let's talk a bit about the feedback. So we have all these different types of users, and what was the type of feedback that we were getting about? So ClojureScript comes out, cool. You can run Clojure in JavaScript. But what were the sort of key pain points that really changed the direction of the project or helped make it better? I can't talk about everything. There's a million things. I could talk for a long time about this, but I'm going to pick a few things. One thing is just build tools. You know, when ClojureScript first came out, the only way to use it for like a year, you had to clone the repo and you had to CD into it and like run the scripts directly from the repo, right? There was no way to install it or use it as an independent tool. And that was terrible. And, you know, shortly thereafter, there was a tool that came out called line-CLJS build, which worked with something called Lineagen. Lineagen is kind of like, you know, a build tool for Clojure. If you do, you know, Scala, it's kind of like SBT, I guess. But the reason the build tool thing is important, it's about first impressions. Like, what is a user's first impression? And when I say a user's first impression, this includes everybody from, this is the first time I've ever written a computer program, to, I've been programming for 30 years and I want to try out your thing, right? So it's extremely important that this sort of experience is good. The reason build tools are important is because ClojureScript requires a build step. When you run Clojure, Clojure runs in the JVM, compiles your code on the fly and dynamically loads bytecode, right? We don't need a build step with Clojure. The thing just goes. With ClojureScript, you have to run a build because you're going to run it somewhere else, and we're not integrated with that thing. That's either going to be Node.js or the browser, right? You're going to have to open up a browser and load that stuff. So the build step is required. So it needs to be good. There, of course, there's tools, Lineagen, Boot, Maven. I don't really want to talk about them. And my experience as the maintainer was that this was really killer for both beginners and for experienced devs. They're like, why do I have to learn all this stuff and write all this stuff when all I want to do is just compile this thing to one script tag, right? Our experience was very bad for a very long time. Bad in terms of like how much you have to understand to do the thing. Very different from something like, you know, at the time like CoffeeScript. CoffeeScript, you could do npm global install CoffeeScript and boom, you just CoffeeScript, pass in the file, you're done. There's nothing else to do. And so it took us a long time to get there, but certainly this was a common thread. People who were just starting were like, this is really cool once I got it working, but man, that was a lot of hurdles I had to get through to try it out. So I sort of started focusing on the quick start. The quick start is our intro. If you like the demo today, I highly recommend go to ClojureScript.org and try the quick start, and then give me some feedback. Feedback is always good. But the quick start's focused on the command line, and it's a complete flow. You know, this is another thing that's really, I think, is really important, especially for ClojureScript. You know, Clojure doesn't take you through a complete flow because, in some sense, Clojure can just run embedded inside of a Java thing, and it just works. There's nothing really to do, which is awesome. But in ClojureScript, we do need to demonstrate a complete flow. So we actually show, even though the program is trivial, we show you exactly what you would do in a production setting, which is to produce production tree-shaken minified code. So the steps in the quick start are exactly the same steps that anybody's using right now if they're deploying a ClojureScript application. So our quick start is, the result is the real result. It's not just a fake little toy thing. And with that, it's been great. I mean, that's been the feedback from that, getting people to see that, oh, there is a complete story from, I just want to test something, to what does it look like in production. So that's the intro that we give. And I think that's definitely got people convinced that ClojureScript is good and serious. The other thing that happened is that, so people who use ClojureScript, they need to use other libraries, right? So I'm going to explain this. There's no reason you would know about foreign libraries. The reason this is a problem is because of Google Clojure. Like, raise your hand if you know anything about Google Clojure, oh, okay, cool. So that's more than I thought. Okay, so Google Clojure was created by Google in 2009. It is what they use to build all their JavaScript properties. They do not use the stuff that people are using in the JavaScript world. They use Google Clojure. Anything that you're using on Google that has JavaScript, it goes through this. If you ever decide you want to commit something to Google Clojure, They have a completely automated process. You sign the CLA, you do a thing, it gets reviewed, and it gets pushed. And if anything in Google breaks, they have a whole automated thing to roll back your changes. This is a keystone in their stack. And so we use it because it does things that JavaScript tooling still does not do. It's a whole program optimizer. It does inlining and tree shaking. Inlining, you probably know, you just take a piece of code and you inline it, and that's good for performance. But it does a very critical thing, which is tree shaking, and this is what's called dead code elimination. So this means if I use a library, and that library has 1,000 functions, but I only use one function, it's gonna crawl that crawl graph to say, what of those 1,000 functions does this one function that you're using depend on, and it will eliminate everything else, right? So this is what allows ClojureScript, which is actually, ClojureScript is about 10,000 lines. The standard library is like 10,000 lines of ClojureScript. I think that ends up being like 50,000 lines or something, 40,000 lines of JavaScript. And after Google Clojure minifies and dead code eliminates a simple program, it's like 22K, 25K gzipped. Right? That's smaller than jQuery, and our library is way bigger than jQuery ever was. So Clojure is also a minifier. It renames everything. So if you write a function in a namespace called mycoollib.foo, the minification is going to collapse that into like a 2-character name. Or, just as this thing that, you've probably seen this before. Other tools do it, but Clojure does this. But the problem is Clojure's whole program, right? It does the whole program. It wants to see everything. And that's the problem for using random JavaScript libraries, right? Many JavaScript libraries use dynamic tricks that Google Clojure cannot possibly understand. The reason it can do dead code elimination is because everything in your program is static. Everything is statically known, right? There's nothing dynamic happening in your program, so it can eliminate the parts you're not using. The moment you start doing like string-based lookups and adding methods to objects via strings, you start doing string-based programming, Google Clojure is like, well, I don't know what you're doing, so we're just not going to do anything, which means that you often end up with programs that don't work. So a lot of JavaScript libraries won't work that are external to the build. That's the problem. You want to use Moment or you want to use some React component, you're not going to pass that through Google Clojure because you're not sure that what you're going to get is going to work. So you keep it separate and you have to provide what's called externs. And this is something that historically that had to be done. So we were able to solve this in a sort of community-oriented way. I came up with a strategy to allow the compiler to support this type of dependency. And then it was up to the community to go and like curate what are the most popular JavaScript libraries. We'll package it up, and then we'll provide the externs for you. And this was fine, right? This was like about 4 years ago when React was just starting to take off. People started curating the most desirable packages and packaging them up and providing the externs so that end users didn't have to care about this. Now, the issue is that 4 years later, it's great for the most popular libs, but these days, there's new high-quality components being written in React, and they're coming out all the time. And so for CLJS, there's just a community overhead. You have to identify the thing, and then you have to understand what are all the steps to correctly produce the package. So there's overhead. There's also the problem of dependency chains are getting longer. And so as they get longer, you definitely get into situations where like, oh, this requires this requires this, and you have to go package up those things in a sensible way. And that's also a problem. So this is something, this is recent. This is 2018. We finally solved this problem, which is that you no longer have to write externs. Externs don't have to be written. And this is another sort of luck of the draw of history, is that when Rich Hickey first created ClojureScript, the convention was that if you access anything outside the build, there's a convention. It's called JS/. JS/ means this is a global thing. It's not going to be in the build. Because this was a pre-existing convention, we can use a trick from functional programming. It's called inference, right? So if you ever go JS/ something, we begin tracking the access patterns for that thing. And we automatically create externs for you. You don't have to create them at all. So now, you can go with Webpack, you can go grab all the Webpack components you want. You can go grab React Select, React Highlighter, all these things, right? And they're crazy, they're huge. Their API surface is massive. And we automatically infer, beginning when you require that dependency, we begin inferring and tracking all your usage of that library, and we automatically compute the externs. And this, of course, is a game changer. You can now just use anything from the Node.js ecosystem
and it works with advanced compilation, and you don't have to know about how it works. We automate it for you through a kind of inference. That took a long time, right? That was like many steps along the way to figure this out. So one last thing I want to talk about before wrapping up is specification. So another thing that I sort of observed over the past 4 years is that Clojure is very actually unique among functional programming languages in that it's untyped, right? There's actually not that many untyped functional programming languages. I mean, I come here and as a general rule, it's like Scala or Haskell. The other big one is Erlang, right? People like Erlang, and I guess to a certain degree Elixir, though I would say Elixir adds certain constructs that make it less Erlang-like on the functional side. But it's Clojure and ClojureScript are pretty unique. I think most of there's a lot of action around the type stuff. So ClojureScript's untyped. And so what does that mean, right? So I've been doing it for 10 years, and I'm not sitting around being like, oh, I really need types. I mean, people say this, but like I've been doing it enough. I've worked on very serious software projects, and it's never the case. I'm like, oh, adding types is going to change my life. It's magically going to become better. Again, because my experience on software projects, the ones that really stink, have nothing to do with Clojure. It's because the process is bad. That's right. It's because the way decisions are made is horrible. It's things keep changing, right? There's no logic. Technologies keep getting added. It has nothing to do with the program that I'm writing, why my experience at this X company is bad. But it is true that as Clojure teams and projects grow in size and ambition, there's definitely a natural movement towards specification libs. So one thing that was very popular for a long time was a thing called Schema. And actually, this is easy to understand, right? It's like test-driven development, right? When you sit down and you write a schema or a spec, it offers the programmer an opportunity to think through the problem space without committing to the solution, right? That's why we like test-driven development. There are these test-driven, fundamentalists, and I think it's a bunch of bullshit. But it is true that what they're saying, it does give you a chance to think about what you're doing. There's lots of ways to do this, but test-driven development forces you to do it. Sitting down and writing a schema or a spec forces you to do this. You can't just be lazy. You have to do it. So I don't believe in the fundamentalist view, but I agree with the conclusion that it allows you to do something that you wouldn't normally do. The other thing that both tests and specs succeed at doing is documentation. What the hell were you thinking when you did this, right? What were you thinking? And adding specifications lets me, without having been there when that code was written, look at the specification and say, these are the inputs, and these are the expected outputs, and these are the sort of invariants that are expected here. And so Clojure has a thing called spec, and this is something that without fail, on every client project, people are using spec. So again, they're happy with this, right? They're happy with this. It does the thing that types would have gotten them. They don't get the compile time errors, but what do they get? I had to sit down and think about what I was doing, and I have a way to communicate to somebody who I may not be able to talk to directly about what I intended when I wrote this code. So specs, definitely I see that. It's a relatively new thing, past year and a half, 2 years. And I think over the next 3 or 4 years, people will better understand how it works, and we can better communicate to people how dynamic typing plus specification is actually a pretty good combo, and it gets you most of the benefits people would expect from like a typed functional programming language. Well, so what's the takeaway? So it's very important areas. ClojureScript projects look like any software project, right? In the end, the type of thing that we're doing, for the most part, looks like any software project, right? Change the name of the technologies, and many of the details end up being the same. And this is good, right? And I think the sort of software craft thing should be talked about more in sort of functional programming circles. I feel like in functional programming circles, there's this tendency towards academia, and people talk down about things in the mainstream that we know are working. We know they work. FP and anger. Functional programming is better. Don't get me wrong. I am 100% convinced I would never go back to object-oriented programming. It's never going to happen, right? I'm definitely caught the bug, and this is the way to do software. I love it. But again, functional programming alone isn't enough. When you look at things like when I look at things like Haskell or Erlang, and I'm like, I wouldn't use those things because when I do show you my demo, that's what's important. I now have source mapping, IDE integration. I can debug the thing. I can use whatever React tools I want. Those things matter a lot for me as well as the potential audience that we want to continue to bring to the technology. We have to think beyond the programming language.
Assess existing practice and identify features to either support or make easier to adopt. I know I need to wrap up. And listen to users. I mean, hopefully that's the main brunt of this talk, is that ClojureScript and Clojure are very much about functional programming is great, but we still have to listen to what people want, because they're coming from other technologies and they have certain expectations, and many of those matter. I think functional programmers and communities, there's, again, too focused on programs, individual programs, micro-level concerns. Again, I'd like to see more thinking at macro level, architectural level, and I'd like to see us meet mainstream on terminology and best practice. And this is why I have a lot of respect for projects like Elm, right? Elm is great because Elm says, okay, we came up with all this cool stuff, but we're using all this terminology that people have to wade through to get to, hey, I can make a cool application. I don't have to spend as much time, and I'm more confident about the results. Why do I have to wade through terminology to get the good stuff? And I think this is something we must change, and certainly in the ClojureScript and Clojure world, we've long embraced. Just meet people on at least on some of the terminology that's being used, because that makes adoption easier. So 2 talks, and I'm done. Check these out. I think these are huge for functional programmers. Language of the system, thinking beyond individual programs. And another one that I think is great, which is speculation. This is one that I love, because this is about, I think, a huge problem in the functional programming community still, which is just versioning. So Clojure is slowly moving to a world where we're thinking differently about versioning, where, functional programmers say, immutability, immutability, but then all your depths are fucking changing. What? Anyways, thanks.
Thank you very much.